Good morning, everybody. This is Mr. Walker with your Ed Puzzle video that goes with the Big Ideas Lesson 2.5. So the goal of this lesson is to determine if a shape is similar, and if it is similar, what is the length of the corresponding piece, or what should it be? We're still working on the essential question of what are transformations? All right, so let's talk about what similar figures are. So, figures that have the same shape but not necessarily the same size are considered similar figures. So, we have here triangle ABC is similar to triangle DEF. So, you can see they're the same shape but not necessarily the same size. Now, there's two criteria or two rules that have to be applied when you're looking at things that are similar. First, the corresponding side lengths are proportional. Now remember, corresponding just means it's the same side or the same angle, but on the other figure. So if we're looking at, let's say, for example, side AB, it corresponds to side DE. And you can also see that in the name of the triangle. AB, the first three letters of the triangle, correspond to DE. Now, there's a lot of different corresponding pieces here. We also have uh, the three other or the two other sides, but we also have the three angles that correspond to each other. So we can see that angle B, see how it has one arc, corresponds to angle E. So remember, if it's a similar figure, the corresponding side lengths are proportional. And the second rule is that the corresponding angles are congruent. So make sure that you write this down, these two rules and the definition of a similar figure. And it'd be probably a good idea to copy down this as an example. All right, so let's go ahead and take a look at an example where they're asking you which one of these figures or which one of the rectangles is similar to A. So what I want you to do is maybe copy these three down, rectangle A, B, and C, and then just try to predict which one do you think is going to be similar to A. I could tell just by looking at them which one is probably the similar shape. All right, so remember there are two rules to decide if a shape is similar. And the first one is, are the corresponding angles congruent? So let's go ahead and take a look at the angles inside of triangle, or sorry, rectangle A. So this is 90 degrees. The corresponding angle in B is 90 degrees. The corresponding angle in rectangle C is also 90 degrees. All right, so those are the same. And it looks like all of my angles that are corresponding are congruent. Remember, another name for congruent is the same. So we have, so far, we can't tell which one of these is going to be the similar rectangle because all the angles are congruent. All right, so let's move on to the second rule. Are the corresponding side lengths proportional? So let's go ahead and look at we'll first start with the length of rectangle A versus rectangle B. So the length, I'm just going to put like a little L for the length. So let's see, we have 6 to 6. So 6 compared to 6. And then when I compare the widths of rectangle A and rectangle B, A width, B width, it looks like I have 3 is comparing to 2. So simplifying these, it looks like 6 divided by 6 would be 1, right? And if I divide 3 by 2, I get 1.5. So I could tell these two numbers don't match up. I have 1 on this side, 1.5 on the other side, they're not going to be the same. All right, so let's go back and we're going to, instead, we're going to compare rectangle A and rectangle C. So let's look at the length of A and the length of C. So we have A length is equal to 6, and the C length is equal to 4. Then we compare the widths. We have the width of A is 3, and it's comparing to the width of C, the corresponding side of 2. So it might not be obvious just yet, but if I go ahead and do a little division here, so 6 divided by 4, simplify, would be 1.5. And if I divide 3 by 2, I also get 1.5. So because these two numbers match up, I could tell that rectangle A and rectangle C are similar. Their lengths are proportional to their widths. So 6 is to 4 is the same thing, is the same comparison as 3 to 2. So that's proportional. So that means rectangle A and rectangle C are similar. All right, let's move on to our next slide. So now with these examples, we know that these shapes are similar. So it says the triangles are similar, find x. Okay, so let's go ahead and try and find out what the x is. So these triangles are similar, so I can tell this side corresponds to this side of this triangle, and this side of the triangle corresponds to this side of the triangle. Now, it might not be completely obvious, but these angles are the same angles. They're congruent, corresponding. So let's go ahead and try to figure this out. The first triangle has a length of 6. The second one has a length of 9. And we have a length of 8 comparing to x. So there's a couple of different ways to figure out what the x is worth. My favorite method is called the cross products. So it's pretty simple little strategy. All you do is you multiply across from each other, and it will equal the product of the other two numbers being multiplied. So I have the 8 times 9, which is 72, and I have the 6 times x, which is 6x's. Now, some number times 6 will give me 72, so think about what number that would be. If you're not quite sure, you could divide both sides by 6, and you can figure out that x, this number right here, 72 divided by 6, is 12. So the missing side length is 12, because 72 divided by 6 is 12. So remember, this is a strategy called cross products. It tells us that the product of these two numbers is going to be equal to the product of these two numbers if they are proportional. And I know they're proportional because we were told already at the beginning that they were similar. So they have to be proportional. Let's go on to our next one. So it says these two figures are similar, find x. So remember, if it's similar, we know that the side lengths are proportional. The corresponding side lengths are proportional. So 14 corresponds to 7. And the x down at the bottom corresponds to the 12 right here. So let's go ahead and set up a proportion. Let's see, the 14 corresponds to 7, and the x corresponds to the 12. Notice that I have all the numbers on the bottom for the smaller trapezoid, and all the numbers on the top are for the larger trapezoid. All right, so in order to solve this one, we could do that same exact thing of the cross products. So I could do 7 times x and 14 times 12. And let's do our 7 times x. So 7 times x is 7 x's. And I'm going to get the calculator out to multiply the 14 times 12. I get 168. All right. So in order to figure out what 7x is, or what 1x is equal to, I have to divide both sides by 7. So divide by 7 here, divide by 7 on the other side, and I get 24. So the x on the bottom is worth 24. Now, you didn't have to do it this way with the cross products because I also noticed something very kind of like a sign at the very beginning that I didn't point out, and I did that on purpose. I noticed that the smaller triangle is half the size, or trapezoid is half the size. So 14 times a half is 7, or 7 times 2 is 14. So if I want to figure out what the missing bottom on the other side is, I could do 12 times 2 because 24 times 1/2 is 12. So there's a couple different ways that you could have figured this one out. Looks like the larger trapezoid was twice as big, so I could have just multiplied everything by 2 and got 24. If it's not obvious, stick with the cross products. All right, and our last question. So this is an example kind of showing a real life problem. So an artist draws a replica of a painting that is on the Berlin Wall. The painting includes a red trapezoid. The shorter base of the similar trapezoid in the replica is 3.75 inches. What is the height of the trapezoid in the replica? So the question, let's kind of look through again. What is it that we're doing? So the question is, what's the height of the replica? Okay, so that's here. And it says the shorter base of the similar trapezoid is 3.75. And it's important to note that it is similar, so everything is proportional in size. So let's kind of just point out some different things. This side corresponds to this side, and the top corresponds to the H. All right, so let's go ahead and use our cross products to help us figure this out. All right, so I'm going to put the larger numbers on top. You don't have to, it's just something that I'm going to do. So the painting side is 15, and that corresponds to the 3.75 on the replica. And that should be equal to the painting height of 12 to the height of the replica. So remember, everything from the painting went on top, everything from the replica went on the bottom. And I matched up corresponding pieces. So let's go ahead and do our cross products. So I'm going to multiply 12 times 3.75 and the 15 times the H. So 15 times 8 is H is 15 H's. And that's equal to 12 times 3.75, which I'll need my calculator to help me out. 5. And then what I'm going to do is I need to get the h by itself. So in order to get the h by itself, I got to get rid of this times 15. So the opposite is divide by 15. So 45 divided by 15, use the calculator, and I got 3. So this h up here at the top is 3. So now after kind of doing this problem with the cross products, I can tell that the painting, everything on the painting is 3 times bigger than the, or sorry, 4 times bigger than the replica. So the painting is 4 times bigger on the lengths. All right, so this goes along with the Big Ideas Lesson 2.5, which you'll do with me on the next day that we meet with each other. Make sure you guys take notes on this. You can go back and forth. You're allowed to skip around on the Ed puzzle just in order to make sure you have the best notes. All right, so have a good rest of your day. I will see you when you come back into class.